Hello students, this is chapter 24, integral 3. We are finally on the last chapter of this course. I think you learned a lot from the chapter 1, but this is the last chapter, but I think the most hard chapter, because this chapter contains all the integration, especially the most advanced concept of integration. So let's get started. This areas and volumes. The topic of this lecture is areas and volumes. These two areas, I've introduced this in the last lecture a little, but there will be more hard thing here. Before we start, did you memorize this? This was on the last chapter, right? The fundamental theorem of calculus, right? So the easy way to calculate this was introduced here, and the final, we are going to learn about how these two are different. This is an area here, and also this is an area, but how can we get this? The height here has to be positive value, right? But this point F, well, let's say this is D here, and FD is not positive, right? So this will be a negative area. So there will be a problem, because area and height and all this mathematical shape thing should not be smaller than 0, right? So this height is positive and this height is negative. You remember all this small n dividing into n strips, and the height is this, and this was one component of this rectangle. All these rectangles. So this dx and delta x is same, and this f will be positive or negative. We have to think if this is positive or negative. If this is positive, then just the area is same as we did in the last lecture. But if this is negative, we have to think a little, because the height will be not this fx itself, because fx is smaller than 0. So we have to do this by absolute value, which means we have to give here a minus sign, and this positive or negative affects this part, right? Which means this part, positive or negative, is important. And the final meaning is that how to calculate this is C to B. If you make this two range same here from here, then this height should be f minus x dx. So this is the answer of S2. We have to give here inside the minus fx, which this is the height. So this a to b will be a to b itself without this minus change. The final value will be S1 minus S2. It will not be S1 plus S2. So this here. So total area S1, S2 will be like this. You have to do this with minus sign. If this is plus, then this C will be erased and added together, which means A to B will come out in the final integration, and this will be the same as this, and it will be S1 minus S2, which is not the total sum. Okay? So you have to think about the sign if the graph is drawn in below this x-axis. Okay? So this is an example. So why don't you pause a minute and do this and I'm gonna write this result here. You all know that this comes like this, right? And these area will be, I'm gonna get this separately and add, which means this one will be 0 to 1 y dx, right? Which means 0 to 1 x cubic square and minus 3 square x square and 2x dx, right? So this is S1. But S2, what I said in the last page was, if you set this in like this, 1, 2, naturally, then we have to add minus sign in the front. Yeah, it is easy, I think. Just the first thinking is hard, but if you do repeat a lot of times, it is easy. Then this will be, so are you students kind of familiar with this polynomial integration? I'm familiar. Yeah, but if you are not familiar, you have to memorize this. So because this all calculation is very basic, so we have to do this 3 times here in just this simple example. So, and yeah, so this means with this 1 and 0 here is from here and here, here and here, yeah, and it means that we are giving here number 1 first, and we will subtract the values with 0. I'm gonna do this here. Oh, actually this is 4. This total value minus this one, which means this is all 0, so it'll be erased, and this will be 1 over 4 minus 1 plus 1, which will be 1 over 4, right? And this one will be 1 over 4 x fourth x third plus minus x squared, and it will be 2, 1. Are you following me? This is just, I did the integration here, and I'm gonna give this number into inside, which means 4 to the power of 4 and power of 3 and minus 1. Right? And I'm gonna change the color here, and this 1 and 1 will be 0, and this, oh, here 1 over 4, it was 1 over 4, just 1 over 4 is left with 2 minuses, so the final answer will be here 1 over 4, and this is 16, and this is 8, and this is 4, which means 1 over 4 times 16 is 4, right? So minus 4 plus 8 minus 4, and this is plus 1 over 4. This is final answer. So this will go to 0, and the final answer is this, which is, this is 1 over 4 and this is 1 over 4. If this final value came out with minus sign like this, then your calculation was wrong. So the final sum, total sum of this area is 2 times 1 over 4, which is half, 1 over 2, okay? So this is the answer. Is it good? I'm gonna go on. So this is kind of broadened concept. How can I explain this? So in the first concept, this bottom line was x-axis. So if the f was like this, then the area here was integral f(x) dx from a to b, then a to b, right? But here, minus 0 was inside, implicitly inside, because you have to subtract this. This was the height, right? But this was just a flat line, so we didn't consider this. But here, this bottom is not flat line, so this height will be fx minus gx. Let's look at the slide. So this height will be fx minus gx, and this height will be gx minus fx, because in this area g is bigger than f, right? S1 is fx minus gx from a to c. A to c, this is red, so I'm gonna use this white one. What was this? This was the bottom line here, and this was the height. So height has to be bigger than 0, which means f minus gx is the right height, because this f is bigger than gx, right? And here, this is also the bottom line, and the height will be not fx minus gx. This is not right, because this will be a negative value, and this will be the height, because g is bigger and f is smaller in this range. So S2 will be like this, and S1 will be like this. This is a little application. Now we are going to look at the volumes. Total area was height and the base. So these two components, with multiplying these two, were rectangle, right? Rectangle. And the sum was like this. But if the volume, how do you get the volume? Like this. This area times this height, right? Let's say this thickness. So it is just similar to this. This was small area, and it was sum. Here, this S changed to V, which is this total area from total volume. And this Sx is the cross-section area, which means this area is this Sx. You have to make this cross-section area into function of x. Then this dx will be this thickness, height, which is, this is x-axis, so this much here with this green-blue part will be dx, right? So this thickness times this cross-section area will be a little volume. And if we sum all the little volumes, the total volume will come out, which means this is small parts of total volume. Okay? So we just apply this concept here to a little wider. It's not that hard. So this is the sum. Do you know this? Can you understand this? This is, yeah, it's good, I think. So this is the final example of our course, and I think it'll be a hard one. Find the volume of the solid obtained by the rotating on the x-axis the region under the curve here from 0 to 1. This 0 to 1 makes this and this, right? 0 to 1. And then if we rotate by the x-axis, what will this point, this line will go? It'll go to further to here, and it'll rotate like this. I am a bad drawer, but I'm gonna make you understand. Can you see this? This will, like a cup will come out if you rotate this on the x-axis, right? Then our goal is to find a volume, which means we have to find this cross-section area, which is Sx, and we have to make this Sx into a function of x, right? Then the final volume will be this 0 to 1 Sx dx, right? Because dx will be this thickness right here. Right here. Right? So this Sx, to express this Sx into function of x, is the most key point in this example, which means this cross-section area will be a circle, and this radius will be here. Oh, let's say this is x, this component here is x, then the y component will be root x, which means this radius is root x here, right? So what is the area of the circle with radius root x? It is pi r square, which means this Sx will be pi times root x square, pi x. So this Sx will be pi x. Then we are almost done. Here, 0 to 1 pi x dx v. And we have to integrate this. Pi is a constant, so pi will come out here, and 0 to 1 x dx, which is pi times 1 over 2 x squared 1 0. So the final answer will be pi right? It'll be pi over 2. So we've looked at the final example, and if you can solve this final example very completely, then I think you made this course clear. And my name was Seongjun Park, your tutor, and if you have some questions, I'm gonna give you my email. Yeah, this is my email, and if you have some questions, I'm gonna answer you if you mail to me. So this was end of my course. Bye bye.